Did you know the universe isn't as colorful as it looks? What if I told you it's actually beige? Yeah, beige. The average color of all the light emitted by all the stars and galaxies out there boils down to a rather boring shade of beige. And that's just the tip of the iceberg. You can actually boil water in a paper cup without it catching fire. Sounds impossible, right? And get this, there's a hidden eighth continent most of us didn't even learn about in school. You're taller in the morning than at night. What's going on here? If these facts have you scratching your head, don't worry, we're about to dive deep and explain all these bizarre truths. Let's jump in. Alright folks, buckle up, because we're about to tackle a cosmic truth that might just make you see the universe in a whole new light, or lack thereof. This revelation is going to change the way you think about the cosmos forever. Here's something that might surprise you. The universe is beige. Yes, the vast, seemingly infinite expanse of space has a surprisingly mundane color. Yep, you heard that right. Beige, the color often associated with simplicity and neutrality, is the average color of the universe. The entire universe, full of dazzling stars, colorful nebulae, and mysterious black holes, boils down to one color. And it's not something wild like purple or blue. It's beige. This might seem counterintuitive given the vibrant images we often see from space telescopes. Pretty mind-blowing, right? How can something so vast and diverse end up being such a neutral color? Well, it all comes down to light. The interplay of light and color in the cosmos is more complex than it appears. You see, the color of something depends on the wavelengths of light it reflects. Different objects in space emit light at different wavelengths, creating a spectrum of colors. When we look at a star, we're seeing the light it emits. This light can tell us a lot about the star's properties. And stars, depending on their temperature and age, emit a wide range of colors, from the cool reddish hues of red giants to the scorching blue-white of massive young stars. Each star contributes its unique color to the cosmic palette. So with all these vibrant colors swirling around, how do we end up with beige? It seems almost paradoxical, doesn't it? Well, in 2002, a team of astronomers at Johns Hopkins University decided to average the light coming from over 200,000 galaxies. This ambitious project aimed to determine the universe's overall color. They wanted to get a sense of the overall color of the universe, a kind of cosmic latte, if you will. This average color would represent the combined light of countless stars and galaxies. And guess what they found? The results were as surprising as they were fascinating. The average color of all that light, when blended together, turned out to be, you guessed it, beige. This discovery added a new layer of understanding to our perception of the universe. They even gave it a fancy name, Cosmic Latte. So next time you look up at the night sky, remember, you're gazing into a universe that's, at its core, a soothing shade of beige. Alright, get ready for this one, because it sounds like pure sorcery, but I promise, it's just science at work. Did you know you can actually boil water in a paper cup? You heard me right. A regular, flimsy paper cup can survive the heat of boiling water without bursting into flames. Sounds like some sort of magic trick, right? But trust me, there's some real science behind this that's going to blow your mind. Let's dive into how this works, and why your average paper cup can handle the heat. Literally. The key to this seemingly impossible feat lies in the surprisingly high ignition temperature of paper. You see, paper itself doesn't just spontaneously combust at the boiling point of water, which is 100 degrees Celsius or 212 degrees Fahrenheit. Paper needs to reach a much higher temperature to actually catch fire, around 233 degrees Celsius or 451 degrees Fahrenheit. Now, here's where things get interesting. When you heat water, its temperature rises, but it can never go above its boiling point. Think about it. When you boil water on the stove, it doesn't matter how high you crank the heat, the water itself never gets hotter than 212 degrees Fahrenheit. It just boils faster. So when you put water in a paper cup and heat it, the water absorbs most of that heat energy and prevents the paper from reaching its ignition temperature. Chapter 3. Sound breaking the light barrier. Hold on tight. Okay, get ready for this mind bender. Did you know that sound, yes, sound, can actually travel faster than light under certain conditions? It sounds impossible, right? But science is full of surprises. I know what you're thinking. But Neil, I thought light was the fastest thing in the universe. Well, you're not wrong, most of the time. Light is indeed the speed champion in most scenarios, but there are some crazy scenarios where sound can take the lead, and trust me, it's going to blow your mind. Let's break this down and explore these fascinating conditions. So, how in the world can sound ever be faster than light? We all know that in our everyday experience, light is way quicker. It's something we take for granted. For example, during a thunderstorm, you see lightning long before you hear the thunder. This is a classic demonstration of light's superior speed. That's because light moves at an insane speed of about 299,792 kilometers per second, or 186,282 miles per second, while sound plods along at about 343 meters per second, 1,125 feet per second, in air. The difference is staggering. So how is it even possible that sound could ever catch up? It seems like a race that sound could never win. The key here is understanding that the speed of sound, unlike the speed of light, is not constant. It varies depending on several factors. It depends on the medium through which it's traveling. Different materials can significantly alter the speed of sound. Sound travels faster in denser materials. This is a crucial point to understand. For example, sound travels faster in water than in air, and even faster in solids like steel. The denser the material, the faster the sound waves can move. Now, imagine a very, very specific scenario, a very, very dense material. We're talking about densities that are almost unimaginable. And when I say dense, I mean really dense, like denser than anything you can imagine here on Earth. This is where things get really interesting. Think about the core of a neutron star, where matter is squeezed together so tightly that atoms are practically touching. This is one of the densest environments known to science. In these extreme environments, the speed of sound can get pretty wild. It's a whole different ballgame compared to what we experience on Earth. In fact, physicists have calculated that under these conditions, the speed of sound could theoretically approach the speed of light. This is a mind-blowing concept. Now, there's a catch. Even though sound waves can travel incredibly fast in these extreme environments, they're not breaking the cosmic speed limit set by light. Light still holds the ultimate speed record in the universe. Chapter 4. Zealandia, the hidden eighth continent you never knew about. Did you know there's a secret eighth continent hiding beneath the ocean? It's not just a myth or a legend, it's a scientific reality. Yeah, I'm not kidding. This isn't some lost world in a fantasy movie or a conspiracy theory. It's a genuine part of our planet's geography. There's an actual real-life continent that most people don't even know exists. It's been hiding in plain sight, or rather beneath the waves. You've probably learned about the 7 continents: Asia, Africa, North America, South America, Europe, Australia, and Antarctica. But what if I told you that geologists have discovered an 8th one, and it's been hidden right under our noses? It's a fascinating discovery that changes our understanding of the world. This submerged landmass, known as Zealandia, is a whopping 4.9 million square kilometers, 1.9 million square miles, about 2/3 the size of Australia. That's a significant chunk of land. It lies mostly submerged beneath the southwestern Pacific Ocean, with its highest peaks poking above the waves as the islands of New Zealand and New Caledonia. These islands are just the tip of the iceberg, so to speak. So, how did Zealandia end up underwater? It's a story that goes back millions of years. Well, like all continents, Zealandia sits on top of a tectonic plate, a massive slab of Earth's crust that floats on the planet's molten mantle. These plates are constantly moving and reshaping the Earth's surface. Millions of years ago, Zealandia was part of a supercontinent called Gondwana, which included present-day South America, Africa, Antarctica, Australia, and India. It was a massive landmass that eventually broke apart. Around 85 million years ago, due to the forces of plate tectonics, Zealandia began to rift away from Gondwana. This separation was a slow but powerful process. This process thinned and stretched Zealandia's crust, causing it to sink below sea level over millions of years. The landmass gradually submerged, leaving only a few peaks above water. Now, you might be wondering, why is Zealandia considered a continent if it's mostly underwater? It's a valid question that has intrigued scientists for years. Well, geologists define continents based on several criteria, including elevation above the surrounding area, a distinctive geology, a well-defined area, and a thicker crust than the ocean floor. Zealandia meets all these criteria, making it a true, albeit hidden continent. Chapter 5. The curious case of your shrinking and growing height. Did you know you're actually taller in the morning than at night? No joke. Every single day, you lose a little height as the day goes on. Sounds weird, right? How can your height change in just 24 hours? Is gravity messing with us? Well, it's not magic, and gravity isn't playing tricks on you. The answer lies in the fascinating world of cartilage. You see, your spine isn't just one solid bone. It's made up of 33 individual bones called vertebrae, stacked one on top of the other. Between each vertebra is a disc of cartilage, a tough, rubbery material that acts as a shock absorber and allows your spine to bend and twist. Throughout the day, as you stand, walk, and move around, gravity compresses the cartilage discs in your spine. This compression causes you to lose a small amount of height, typically about half an inch to an inch. Now here's where the magic happens, or should I say, the science. When you lie down at night, the pressure on your spine is relieved, and the cartilage discs can rehydrate and expand back to their original size. This is why you wake up taller than you were when you went to bed. Think of it like a sponge. When you squeeze a sponge, it gets shorter and wider. So there you have it. From the universe being beige to secret continents and sound outrunning light, today's facts prove that our world and the universe is full of surprises. Remember, the more we learn about the universe, the more we realize how much we don't know. So keep that sense of wonder alive and never stop questioning the world around you. If you learned something new today, hit that like button and don't forget to subscribe for more mind-blowing facts and insights.